you, Dr. Khan.
Thank you, Lizelle. Good afternoon, everyone. I trust that you're keeping safe and well during this difficult period. We were asked today to speak about a very interesting topic, the potential use for blockchain in the supply chain in the pharmaceutical industry. Now, as most people, when I hear the word blockchain, the first thing that comes to mind is Bitcoin. And the next thing after that comes to mind is volatility. Now, as a trader, I love volatility. But I'm sure many of you guys are thinking that in industry, how do we adapt something that's got severe volatility? So I thought let's start off by just giving a brief introduction so we can differentiate between some of the terms. Now, I'm certain most people know about Bitcoin as a cryptocurrency, and there's multiple or thousands of other coins you could mention by name. But what's really important here and for our talk is blockchain. So blockchain was invented by Satoshi Nakamoto in 2008. This is the underlying technology for all types of cryptocurrency. It's not a coin, it's rather the ledger which we use to record the transactions of the coin. So to put it simply, it's a data structure in which a record of all transactions are secured using cryptography, and this is maintained across several computers that are linked in a peer-to-peer network. The direct benefits of blockchain is that it's highly secure. It maintains an adequate and secure history of all transactions. It's transparent and it's decentralized. So looking at some of those points, we can start to see that there is potentially some industry use for blockchain itself. And then we asked ourselves, why do they want us to speak about the pharmaceutical industry? Now, going back a few years, it comes down to one line in one of my favorite movies. And it goes something like, my father wrote in his book, Chapter 1, Page 1, Paragraph 1. What is the answer to 99 out of 100 questions? And that answer is quite frankly money. The pharmaceutical industry was worth 1.25 trillion US dollars at the end of 2019. Now, there's a lot of money going around there and there's a lot of place for innovation. But it does affect each of us every single day. Let's say, in this highly developed world that we have at the moment, how often do we actually stop to think about the product that we've consumed? What has it gone through to actually come to us in the form that we know and take it? So let's say you go to a doctor, the doctor diagnoses you with high blood pressure and then gives you a little, well, let's call it cryptography on a little script which he gives to you. You go to the pharmacist who then gives you a medication which you take and you trust that this thing will maintain your blood pressure. Now, making sure that medication works and is acceptable when you take it is the pharmaceutical industry's job. They start with sourcing raw materials and ends with delivering the appropriate medication with the right quantity, with acceptable quality, to the right place, at the right time, within costs that are acceptable to the health system. Now, looking at that, there's many variables, and each one of that variables can affect us as the end consumer. So having a system that could potentially maintain a secure history of all transactions, be it in the development, production, and supply, in a transparent manner, and is not controlled by a single authority, could be very advantageous to us and to this industry. So going forward, we're going to have some exceptionally interesting speakers talk about the industry, and after that, we'll have some questions and answers. First up, we've got Dr. Stewart Southey. Stewart is an anaesthetist by trade with over 20 years of clinical medicine experience. He was awarded his MBBCH at the University of Witwatersrand and thereafter a fellowship of the Royal College of Anaesthetists in the UK. He was admitted to the GMC Specialist Registrar in 2008. Whilst working as a consultant, Stewart completed his MBA at the Open University and led many management and transformation initiatives in Poole Hospital. He has worked with Candesic, which is a leading London healthcare strategic consulting firm, and has subsequently focused his experience into emerging technologies in healthcare with a special interest in blockchain. In 2019, Stewart graduated with a master's in blockchain and digital currencies. After Stewart speaks, Dr. Mehran Zarrebini, the CFO of PFE International, a diversified group of companies in Southern and South Africa, will speak. He earned honors in chemical engineering from Loughborough University, a PhD in chemical engineering from the University of Cambridge, and an MBA from the University of Stellenbosch Business School. Mehran graduated with a master's in blockchain and digital currency from the University of Nicosia and is the senior partner at Katina Consulting. Mehran became fascinated with Bitcoin in 2012 when he was a student at USP. He actually purchased his first Bitcoin during his economics class. He subsequently started trading cryptocurrencies during the crypto and ICO hype in 2017. He continues to believe in the future of cryptocurrency and the opportunities they present for the unbanked and underbanked in developing nations. He also mines Ethereum in KZN since 2017. After that, I'll give it over to Stu, and then he'll pass on to Mehran after that. Thanks, Stuart.
Great, thank you very much, Ridwan. I think you'll stop sharing your screen and I'll start mine.
Yes, I stopped.
1 second. So yeah, good afternoon, ladies and gentlemen. Thank you very much for joining us today on this webinar. We'd like to thank the University of Stellenbosch for inviting us to present to you today. And I really hope that you'll all find this very useful. Before we begin, I'll just add a few introductions. I know Ridwan has already started. A little bit about Katina Consulting. Essentially, we are a consortium of consultants from across the globe that are working together. At present, there are 23 of us, and we range from a multitude of industries, including we have 3 doctors, a lawyer, Mehran is a chemical engineer, and an economist. All of us met whilst doing our digital currency masters, and so we're linked by our shared interest in how blockchain can transform business and society. We believe our uniqueness is that we have a broad industry experience in multiple industries, but also extensive blockchain know-how, and this allows us to advise strategically and operationally for our clients. Katina has also secured partnerships with 5 well-established developer firms, and so we're able to provide vetted technical expertise as well as the business strategy consulting, and our partners work with us to help build business solutions as required. As Ridwan said, my experience is as a consultant anaesthetist in the NHS and in the private sector, and as a healthcare strategy consultant. For the last 3 years, I've been advising companies that are building blockchain solutions. I was originally part of the medical chain team, helped them raise $24 million at ICO, and advised on the building of a blockchain-enabled electronic healthcare record solution. But my current projects include working on remote patient monitoring, COVID-19 track and trace solutions, and an AI and IoT-enabled hospital automation project. My colleague, Dr. Mehran Zarrebini, has been involved in the startup and management of a number of companies in South Africa, particularly with an emphasis on sustainable manufacturing. And he recently established the largest tire recycling facility in the country, where the supply chain is inherently complex since it involves public, private, and consumer participation and entrepreneurs with eco ideas. So please reach out if you have any of those. And that's basically what I've just said. So taking a brief look at the agenda today, first I'll present my understanding of the current and the short-term challenges in the pharmaceutical supply chain, and then follow with a broad overview of blockchain, how it works, as well as the value proposition that we believe blockchain has in general terms. Dr. Zarrebini will then follow with a review of the heritage supply chains solutions and where and why we see potential benefit for blockchain, specifically in the pharmaceutical industry. Mehran will then present a blue ocean strategic approach to determine the future profile of a blockchain company or solution in the space. And then the final 10 minutes or thereabouts will be an open Q&A session. Please feel free to put questions in the Q&A in the chat window below, and Ridwan will facilitate. So there are clearly some challenges ahead in the pharmaceutical industry. Remaining agile and adapting to a changing business environment is critical for companies to remain competitive. And the supply chain has always been a significant percentage of costs for pharmaceutical firms. So now, as we see some interesting changes on the horizon, it is even more important that it is well managed. Those that are innovative are likely to have an edge over their competitors. Several challenges are visible along the chain. With many patents expiring over the next 6 years, companies are likely to see revenue significantly dented. And in spite of great efforts having been made in recent years to improve supply chain efficiency, most still have significant work to do before smooth production scheduling or make-to-order manufacturing is a reality. And the consequence is that there remain inventory challenges, tying up working capital and overheads at significant cost. Also, the pharmaceutical product range has become much more diverse, and manufacturing and distribution have become much more complex. So with biomarkers, stem cell therapies, and precision or genomic medicine becoming increasingly prevalent, novel approaches are becoming necessary to sustain efficiency. Different product types and different patient segments require different supply chains, and shorter product life cycles also adding to the complexity. And in some cases, like personalized medicines, final production may need to take place at the point of care or pharmacy. So a strategically designed supply chain as a means of differentiation may add economic value. There are a number of forces, both internal and external to the industry, that motivate supply chain innovation. Live licensing allows for incremental product launches, but has the consequence of more gradual revenue growth and subsequent return on investment. So adjusting the supply chain accordingly will be important. Also, the growing emerging markets present product portfolio challenges and security risks requiring novel approaches. Reduced incomes and higher levels of self-paying patients influence the product and the service designs. And additionally, the number of recorded cases of counterfeit, stolen or illegally diverted medicines has risen nearly 9-fold since 2002. Pharmaceutical companies are increasingly also under greater public and regulatory scrutiny. With the number of recalls up 50% year on year, supply chain compliance and track and trace improvements are vital to satisfy these requirements. With global warming and water shortages coming more into focus, many companies will be considering their manufacturing locations and methodologies, and this will naturally affect the supply chain as options are explored. Towards the patient end of the supply chain, we see new models of healthcare delivery evolving. With self-administration of medications and community or home-based care on the rise, we can expect the distribution network will widen even further. And e-prescribing and the digitalization of health means that supply chains may evolve to enable factory-to-patient delivery of medicines. Coordination with companies such as Amazon may prove beneficial in this scenario. As outcome-based care becomes more prominent, pharma companies are under greater scrutiny to demonstrate the value that can be derived from their products. And so adding services that complement these products will add further complexity to, but can be potentially be supported by a robust supply chain. So with all of this in mind, data-driven decisions in the supply chain are becoming increasingly critical for value creation. What is more important is the need for integration and coordination of the many data silos across the supply chain. And in all the reports that we have read, the consistent message is that standardized data and processes, data sharing, contract optimization, and stakeholder collaboration are essential for any actionable real-time data analytical insights. So the ability to use this data for operational decisions where rapid responses in supply and demand are required is likely to be extremely valuable. Dr. Zarrebini will focus much more on the value proposition of blockchain later on, but for now, it's worthwhile to say that enhanced data integrity, increased cross-party trust, and the use of smart contracts, we believe that the focus on process automation, enhanced track and trace capabilities, and integrating multiple supply chain components will pay large dividends. Even without integrating the three main supply chains, which are healthcare services, medical devices, and pharmaceutical supply chains, allowing all pharmaceutical supply chain stakeholders to have a real-time view of the current state of the chain will allow more accurate planning and delivery. So to summarize thus far, I would say there are significant challenges ahead for the industry, and a supply chain that adapts to these challenges will result in economic value And this may even be a way in which companies can differentiate and compete. And it is crucial that data integration and sharing, as well as cross-party trust, are essential to achieve this. So before we explore the basics of blockchain, I'd like to pause here and take a quick poll from the audience, get an idea of the level of understanding of blockchain and the likelihood that you believe blockchain will influence supply chain management in the next 5 years. I believe there'll be a poll coming up on the screen. There we go. If you could all just answer, and then we'll have a look at the results. I don't know if we put a time on this, maybe maybe 10 seconds or so for this question, and then go on to the next one. Should we do question 2? Has everybody answered that one? Okay, great. Who's managing the questions? Can we just move to the next one, please? Ridwan, do you know what?
I think Lazelle's managing the questions, but we've just changed it.
Okay, there we go. That's question 2. Brilliant. So it looks like most of the audience is novice or relatively unfamiliar with blockchain. Okay, that's very interesting. And we have a converted audience already, selling to the converted. Brilliant. Okay, should we, if we could, if there's nobody else who wants to answer, that's great. Brilliant. So about 2/3 of you think that it'll improve the supply chain. So if we can, we'll carry on with the rest of this, if that's all right. Now I think understanding. So Lizelle, should we stop the poll? Has it stopped for everybody on the screen? I can. Right, I'll move on to the next slide. So understanding the deep technical details of blockchain is not necessarily relevant, I don't think, or appropriate for today's discussion, but instead I think exploring the basic principles of blockchains and the potential value that can be derived from the application of these ideas would be useful. And so essentially, if you picture a spreadsheet that is duplicated thousands of times across a network of computers, and then imagine that this network is designed to regularly update the spreadsheet, then you have a basic idea of a blockchain. And I guess what we have, therefore, is a database which is distributed so that all network participants will have a copy. No single participant would be in control of the content, but rather as all the parties broadcast changes to the database, a current state of truth is then established by the protocols on the network. This establishes consensus of what data is valid. Only once agreement is achieved across the network can the new truth state then be established. Each state change is then time-stamped and permanently recorded in an ever-growing chain of records so that a fully auditable trail of states of agreement can then be viewed by all parties. So I like to compare this with the time machine screen in the Apple computers, because visually I think it gives a flavor of a sequence of states of now or previous states all linked together in time. So each state will have its own unique digital fingerprint, which is dependent on the content of the transactions at that state. And these fingerprints, called hashes, as you can see on the slide, any change in a transaction will change the fingerprint. And so for a given input of data, the output will always be the same. Although it's not possible to derive the contents from the fingerprint, it is easy to verify that the contents have been altered, because the fingerprint will not match that which is expected. And additionally, the fingerprint from each state is included as content in the subsequent state. So what this means is that alterations in one state will have repercussions further downstream and will be immediately visible. In practical terms, if a nefarious actor wanted to alter the record of any given transaction, they would have to alter the record on every copy simultaneously. And then they would have to ensure that the subsequent blocks in the chain are altered too, in order to keep a cryptographically consistent account that all can agree on, to therefore achieve consensus and a state of truth. And it is worth mentioning here that although there's different consensus mechanisms for different types of blockchain solutions, it's probably not the time to go into permission versus public blockchains. Although I do think it is important to say that there are degrees of decentralization and there are trade-offs between privacy, security, and scalability, depending on the desired levels of trust and functionality of the system. And so the level of trust and the number of parties in the network, amongst other things, will determine the choices of solution. Another fundamental component of some blockchains is their ability to run smart contracts. And for those unfamiliar with the term, a smart contract is a self-executing and self-enforcing computer program that executes the terms of a contract. Each copy in the network executes this set of instructions so that the consensus continues to exist that a task has been performed. And in theory, the complexity of these contracts can range enormously, as you can see, and can represent anything from a single instruction to a complete set of rules that govern entire autonomous organizations. When employed, smart contracts can be used to ensure efficient, unambiguous, and automatic execution of agreements, which can be viewed instantly across the network by all participants. So it stands to reason that this level of automation and clarity can speed up processes dramatically and at great cost savings. So to summarize the value, the value proposition of blockchains and the use of smart contracts, what the system provides is essentially a communications channel implemented as a peer-to-peer database, which allows multiple entities with diverse economic interests to collaborate where it is natural to cheat or seek advantage. And when presented with information, a participant can self-verify the content and author of a record, the state before and after the record, and whether the record is complete without addition or omission. And by creating a real-time, visible state of now that has been agreed across the network as valid, blockchains enhance transparency, reduce frictions, broker trust, improve security, and provide confidence in the integrity of data. And because cryptographic signatures are employed for each transaction, a full audit trail and greater accountability is achieved. And with no central point of failure, the system is always on and not controlled by any single entity. So the biggest question that companies may have in all of this is whether the investment is worth it. And at face value, I would say it would appear that there is enormous cost-saving opportunities from process automation and improved efficiencies. And the pharma supply chain has clear deficits when benchmarked against other industries. As we see in the slide, several areas have been identified where innovation may save billions of dollars. What is perhaps less apparent are the potential revenues from deploying such solutions. And it may be that companies can create market leadership through innovative supply chains, may be able to sell or license their blockchain as a service to others in the industry. Enhanced data integrity may bring with it new insights as well that generate new opportunities, particularly in combination with AI. Faster payments may also be possible via blockchains using native cryptocurrencies, and improved supply chain visibility may lead to recycling opportunities. a World Economic Forum report suggested that a blockchain may increase trade volumes by 15% and may increase global GDP by 5%. Though a large caveat I would say here is that stakeholder collaboration is essential for success. The technology is by design a tool for collaboration and permits trust to be brokered where it otherwise may not exist. So with all the above in mind, it must be stated that blockchains, although not a panacea for all ills, with the right use case, may have the potential to be fairly transformative. You probably have seen many different models designed for assessing whether or not a blockchain is an appropriate technology to employ. One such model here from the World Economic Forum is evident. I won't go through it, but in short, if you are exchanging a digital asset of value or managing contractual relationships, and you normally rely on a third party to broker trust, then a blockchain may be useful if you require a permanent authoritative record of events where multiple parties share right access and don't necessarily trust one another. And I'd like to hand over to my colleague, Dr. Zarrebini, who will carry on telling you the rest. Thank you very much.
Thank you, Stuart. Just bear with me. I'm going to share my screen. Great. I hope everybody can see that. So thank you and good afternoon once again. There's no doubt that supply chains evolve in complexity as the healthcare system is more developed within which they operate. So from an ad hoc system in developing nations, which tend to be unstructured and ill-defined with little metrics in place for performance measurement, to more integrated and extended models in the developed world. And the integrated approach kind of strategically focuses on improving customer service and achieving its health improvement objectives. So health commodities are managed and its supplies across partners, logistics functions and health system levels, meaning that it sets goals and monitors overall system performance and its individual functions. And at that extended model stage, supply chain management has expanded to cover institutionalized coordination between different systems and suppliers that serve the different kinds of markets. So this stage largely represents a challenge even for private sector supply chains in developed countries, because it requires significant amounts of operating trust among different organizations, and hence providers, suppliers and payers must share data to link products and their respective outcomes. And by doing so, they must create a network advantage, leveraging from the strengths and resources available from different suppliers. So if in their current most sophisticated forms, a number of challenges still persist. And these arise and exist due to different stakeholder incentives and goals, and information fragmentation and the issue of communication failure. There are, however, various strategic technology trends for supply chain that have been suggested and how they can provide a competitive advantage in the future. A good one, for example, is the use of artificial intelligence to enhance and even automate decision-making and remake the customer experience. That's going to be important into the future. An example of this is a mobile application that utilizes machine learning capabilities to provide skincare products upon analyzing data from cameras, which can be used to collect buyer behavior data and ultimately determine the demand for skincare products. Adoption of IoT devices is growing in various supply chain domains, and these kinds of devices have been utilized in sourcing, logistics, demand management, and services. And these include improved asset utilization, higher uptime through remote monitoring and maintenance, and improved customer service by better understanding customer and their needs, and proactive responding to and shaping customer demand. One of the most recognizably implemented technologies today is virtual personal assistants, or as we know it as chatbots. And they're taking interaction to the next level with the addition of conversational commerce. Not only can they handle discovery questions and offer solutions without any human agent involvement, but these kinds of systems can also enable transactions. They can handle payments, ensure delivery, and provide customer service. And there are various other technologies that are also being utilized. If we have a look at the market trends and dynamics, it's certainly evident that in recent years, the main trends surrounding healthcare supply chain have been to improve operations efficiency under value-based care and the demand for an increase in cloud-based solutions. The supply chain is being viewed as much more a strategic enabler of health system objectives than it has been done in the past. So there's no doubt that some of this is largely being driven by the economics of healthcare changing over time. And if we have a look at the CAGR of global healthcare supply chain management, it's achieved traction of about 8.4% in the last year alone, and that's going to reach approximately $2.3 billion US. And it's going to be projected to grow at a rather staggering compound annual growth rate of 40.2% in the next few years, up until 2023. But there's been a seismic shift in global business environments, such as increasing competition, higher operational expenditure, growing fragmentation of the healthcare industry, shortening product life cycles, and the crumbling of trade barriers, supply risks such as political and regional uncertainty. And these are all creating uncertainty for the adoption of healthcare supply chain management. And the changing external environment is compounded by the transformation of the business environment internally. An example of this, for instance, is growing organizational size, growing complexity of business, outsourcing, multiple vendor management, and so forth. So the advancements in tech, such as analytics, machine learning, and the advent of social media and big data, coupled with growing capabilities of technology, creates a situation of winner takes all. So early adopters of supply chain management solutions can have a critical advantage over those who fail to understand. Supply chain management is obviously one of the most promising areas of emerging blockchain systems. Proposed benefits for healthcare can be seen in a number of use cases demonstrated here in pharmaceuticals, global health donations, medical devices, and durable goods. And some of the use cases are demonstrated here, but they include accountability in shipping, tracking, and the transfer of goods, the ability to reduce counterfeiting and theft, and also help better manage inventory and stockouts, expirations, and misuse, some things that we've experienced in the last few months with the COVID-19 epidemic. And the other four use cases for blockchain that are essentially well suited for the supply chain are demonstrated here as well. But one of the most compelling use cases is drug quality and track and trace. Certain regulation requires electronic interoperable systems to identify and trace prescription drugs distributed through a particular country. Controlled substance monitoring is again very important. An example in the United States is that of the federal government increasingly holding the pharmaceutical industry responsible for monitoring the supply chain for illegal and out of patent ordering of opioids, and is penalizing distributors. So the manufacturers are becoming concerned that they too will soon be held largely accountable. Cold chain monitoring is vitally important to ensure the temperature integrity of pharmaceuticals across the supply chain according to various local and international guidelines and regulations. Cold chain shipments are projected to grow substantially in the next few years. And lastly, active pharmaceutical ingredients. Monitoring the source of these and the provenance of ingredients from raw materials through the active pharmaceutical ingredients stage manufacturing and final product manufacturing is really subjected to increasingly stringent regulation. So therefore, there are various trusted partners who need immense amount of visibility of the supply chain and verifying the journey of a drug from manufacturing to the administration into a patient. And if every entity on the supply chain can have this visibility of inventory and audit the distribution of the medicine, that certainly makes it more difficult for counterfeits to reach the market. It's only therefore quite a reasonable question now to ask, what are the advantages of blockchain over other current systems in use? And put simply, since records are distributed across multiple areas and are updated as each block is created, there's always a high level availability of the data. So even if a large number of nodes fail or are shut down by an attack, the data is still going to be available for people to access. In addition, since the system is regularly updated with the latest block, Accessing any of the active nodes means acquiring the latest data, even in the event of an attack. It's kind of a highly desirable trait for network security. And the major issue with centralized systems from a network perspective is that they are prone to attack and act as a single point of failure. We only need to look at the banking industry for good examples of that. A huge amount of cost goes into ensuring the security of the network. So while partnerships and consortiums are usually created with best intentions and with all of the necessary legal agreements in an attempt to protect all the parties involved, there still lingers the concern of trust, especially in cases where the parties involved may be competing in other areas. Because of the decentralized nature of blockchain, the issue can be significantly mitigated as trust is not needed in terms of processing data as well as storing it. So verifying that one has the same information that another party has is relatively easy to do without the need for additional trust among the parties involved. So in order to gain an understanding of the current state of play within the competitive landscape, we begin to assess various companies developing these solutions for healthcare supply chains. And there's obviously a large number of organizations in the process of developing the solutions, and we focused our attention on blockchain companies who are specifically developing certain healthcare solutions. They are Modem, MediLedger, and BlockVerify. So Modem's solution portfolio addresses three main challenges in today's supply chain: collecting digital data and monitoring relevant events in the physical world, automating business processes across an ecosystem, and optimizing the supply chain based on trusted insights and predictions. The MediLedger project is very popular and is built to give pharmaceutical partners a way to keep up with evolving track and trace compliance regulations, as well as finding better ways to partner inside a shared ecosystem. BlockVerify provides a solution that has a recorded history permanently recorded into the blockchain to track pharmaceutical shipments throughout the supply chain and ensure that the consumers ultimately receive an authentic product. So by looking into the strategic position of these companies, we can assess whether they are capable of creating a leap in value for both buyers and the company, and then see what a blockchain company offering in the future requires to create cost savings and buyer value. So in this slide, we essentially show the graphical depiction of a company's relative performance across its industry's factors of competition. And if we have a look on the x-axis here, we show the range of factors that the industry considers key or essential to the promotion of their solution. So eliminating complexity around the product offering is certainly a key focus for healthcare solutions. A simpler supply chain experience, more user-friendly processes are needed to unlock valuable insight and enhance innovation. So products are becoming more complex and regulatory scrutiny certainly more stricter, and product life cycles are changing, and pharmaceutical companies are expanding their product offerings in order to try and remain competitive and gain greater market share. And these blockchain solutions are particularly interesting where a network of different players in different countries or geographies have to coordinate their actions. So these partners must find ways to collaborate more effectively, capture the benefits of high-performance supply chains beyond organizational borders and across this complete healthcare value chain. But blockchain solutions are certainly not going to disrupt healthcare overnight. The solutions here that are presented are largely in a state of development and yet not commercially available, and various aspects of funding, governance, and collaboration need to evolve further before broad-scale adoption and integration of business processes take place. Companies developing POCs at this stage may gain a first-mover advantage with practical use solutions and functionality as the technology matures. So Modem uses shipment-specific contract functionality on the Ethereum blockchain, coupled with various IoT devices to store measurement hashes with respect to temperature for shipments of pharmaceuticals, where temperature can have a detrimental effect on drug safety and quality. In fact, temperature control, shipment visibility, and inventory management were identified as the top challenges facing global healthcare pharmaceutical delivery. And heritage supply chain systems, including those that are web-based and cloud-based, they don't really provide a holistic and complete overview of the production and movement of products. The interoperability of these future supply chain solutions is very desirable and will have a high impact on the efficiency of costs within and the costs within the supply chain. So here we just present a very basic grid of the 4 actions framework for blockchain focused supply chains. And the grid is really a simple matrix derived from the previous slides discussion that drives companies to focus simultaneously on eliminating and reducing, as well as raising and creating. So by eliminating complexity and cost in the supply chain and raising and creating several other factors we've discussed, the value trade-off can be broken, creating that buyer value, leap in buyer value for organizations wishing to implement these kinds of solutions. So here we expand on the industry's 4 factors of competition to include a future strategy canvas, which details the future prospects of an organization developing a blockchain solution. And the future entrant differs dramatically from both a heritage supply chain solution and that of an existing blockchain solution that we've discussed previously. And for ease of reference here, I've just included that of Modem.io that has been included on the strategic canvas. The strategic profile of the future entrant has clear focus, and it emphasizes 4 different factors: global presence, smart contract integration, which we've discussed, IoT device integration, and the last one being interoperability. And by focusing in this way, the value curve of the future entrant can certainly stand apart. So divergence from the industry's value drivers is a key to a blockchain supply chain company's success. And those incumbents that focus on collaboration, but also on co-opetition, global presence, and have a high level of interoperability with governance and simultaneously achieve low cost, are certainly likely to create the most value innovation and remain sustainable. But there's a challenge. And when we look at operationalizing blockchain, it's clear that business leaders have trepidation about wading too deep into uncharted waters. Perhaps it's that deep realization that implementing blockchain in any legacy paradigm is very difficult. There's kind of a lack of permanency in blockchain implementations and future thought leadership around them. There's obviously many fluffy white papers filled with buzzwords that are intended to confuse rather than simply to inform. And implementing a value-generating blockchain is by no means a trivial matter. It requires a rewiring of business ecosystems and interactions which ultimately result in change, disruption, and transformation. But that's not the only problem. For many businesses, the legacy monster is alive and kicking. The majority of companies, and especially large multinational ones, have 1 foot in the future and 1 foot in the past, or 1 foot in the here and now. 1 foot looking forwards towards enhanced data insights afforded to them by machine learning algorithms and artificial intelligence, and 1 foot firmly in the past where operational worries continue to fester around. And while there are a number of technical hurdles in operationalization of blockchain, the single most valuable precursor or prerequisite is having thought leadership, knowledge capital, and transformative thinking required to have a viable long-term strategy. And understanding this pathway to commercialization and operationalization from the initial use case to POC and finally to achieve scale while managing this change is very, very key. But before wrestling with questions of tech, resources, and staffing, a more fundamental question maybe who should be involved? The simple answer is a group of partners that participate in processes and outcomes guided by an agreed upon set of standards. Blockchain development and implementation requires collaboration in order to set standards and develop infrastructure. The key is to identify who specifically should participate and what the roles of those individuals will be. One must also be aware that the consortium should be adaptable and scalable as the technology matures into the future. So there's no doubt that blockchain is a foundational tech and its implementation will bring many challenges, but can also offer great rewards. And early adopters could see the benefits sooner than most, while potentially establishing themselves as leaders in areas that should only grow with importance over time. So to summarize, blockchain leads to shifts in the business value chain. It enables forward platform-based business strategies, largely based on externalities, interactions, and demand-side economies of scale. Understanding its application certainly doesn't occur in isolation or in a vacuum, but is very important that all business influences, objections, and questions are considered. The blockchain could not only help us increase the agility during extraordinary black swan events, but also help us operate better in day-to-day operations. The underlying protocol can be repurposed and customized to advance any supply chain. From personal protective equipment that has been in such short supply, especially over the last few months, to products in any industry. And as we wake up to the fact that our health and economic welfare is interconnected with those many thousands of miles away, it certainly becomes clearer that we need to leverage our global resources to effectively fight large-scale problems. Blockchain could help us do this more safely and efficiently. And from our perspective, our approach is largely to determine the feasibility of implementation for our clients using different strategic frameworks. And through our established partnerships with various developers around the world, we can then develop a POC if applicable, and based on the successful outcome of the proof, we would then scale the solution for implementation. But the key here is to ensure the correct technology is developed based on each client's business model and strategic objectives. Thank you very much.
Thank you, Stewart and Mehran. It was very interesting. Let's ask before we summarize, does anybody have any questions? If you do, feel free to type it. I'll mention exactly what you've asked, and then we can take answers from there. But I was sitting on the edge of my seat for most of your talk. It's very intriguing. It's definitely, I mean, working in health for a long time, there's a lot of places I see that can definitely benefit. And I suppose the biggest hurdle is going to be, well, this is how things have been done. This is the legacy. How do we get people on board to actually move forward and change? One concern I did have, I mean, looking at blockchain, is that, well, obviously all information is being recorded in every particular node. Wouldn't that mean that anybody viewing that network could particularly decipher what was done somewhere else? And that for, for privacy on particular industries would cause people not to want to collaborate. So if I've got pharmaceutical company A and pharmaceutical company B, both sharing a particular chain where they say, well, we can see what our users want. If A had to look further back into B's history, they could see their strategic suppliers. Would that be an issue, you'd say?
Yeah, I mean that's largely the case if it was a public blockchain. For instance, a good example, as we've mentioned before, is that of the Bitcoin blockchain. So every single transaction, if you're an active participant in the network, you have every single transaction available for you to see, from when the first pizza was bought with Bitcoin back in 2008, and that whole record of transactions is publicly available. However, there are a lot of private blockchains that are available or being developed by consortiums, such as IBM has one available, and they've been particularly useful in terms of utilizing temperature to follow transactions from the shipment of roses from Kenyan farmers to the marketplace in Amsterdam, where temperature is the controlling. Now, there's a lot of participants in that particular supply chain, such as packers, shipment companies, and that kind of thing. Now, on a private blockchain, only certain parts or certain transactions specific to them would be available to them at any point in time. So it doesn't need to be a public blockchain. If it's a private blockchain, all those privacy concerns would be taken into consideration and dealt with.
Okay, that makes a lot of sense. I suppose specific companies can give specific information, and that would allow collaboration. I mean, the point you mentioned, it can create trust amongst parties that you need to interact with each other, but you may not trust him. And I think that's a beautiful thing. We've got a question from Martin van der Kerk. Can data ever be permanently deleted from a blockchain?
Certainly on a public blockchain that cannot be deleted. So if the information is incorrect, being put into the blockchain as a verified transaction, then it's still recorded there. So it remains within that blockchain. So you cannot permanently delete it. But obviously, if you have a private blockchain, then obviously those kinds of transactions, if they were incorrect, could be verifiable by certain actors who had various permissions within that blockchain, and they could be deleted.
Okay, perfect. And a rough cost, gross estimation of blockchain cost? So if you had to implement...
Yeah, it would vary depending on project to project, depending on its complexity. I mean, a lot of the projects that we've seen, many of the solutions don't even actually require blockchain implementation. This can be done by developing a sophisticated form of database and resolving a problem which